In this video, we're going to talk about the malonic ester synthesis reaction. And so we're going to start with diethyl malonate, which looks like this. And this process is very useful for making carboxylic acids. So there's two acidic alpha hydrogen atoms on this carbon. The first step is to use a strong base, like ethoxide, to remove one of those two acidic hydrogen atoms. And so after this step, we're going to have a negative charge on the alpha carbon. Now the next thing we need to do is react it with an alkyl halide. Let's use methyl bromide. So now we have this molecule. If we want to, we can add two R groups, but for this example, I'm just going to add one. The next step is to acidify the solution. You can use H3O plus or a mixture of water and hydrochloric acid. And so what's going to happen is both ester functional groups will be converted into a carboxylic acid. So this is what we now have. The next thing is to heat the solution. Once you heat it, decarboxylation will occur. And so we're going to lose one of the two carboxylic acid functional groups. So therefore, we're going to get this product. And so the malonic ester synthesis reaction is very useful for making substituted carboxylic acid molecules. So the generic formula looks like this. On the alpha carbon, you can add one R group or you can add two R groups because there's another alpha hydrogen that we can take off. Now let's work on this example problem. Go ahead and predict the major product of this reaction. In addition, write a mechanism as well. So in step 1, we're going to use sodium ethoxide. And then in step 2, we're going to react it with butyl bromide. And in step 3, H3O plus. And then step 4, we're going to heat the solution. So feel free to pause the video and work on this example. So let's start with the first step, and that is deprotonation. And so right now we have this intermediate. And then in the next step, the carbon with a negative charge is going to attack butyl bromide. And so we have this product right now. So we've added 4 carbons to the malonic ester. And then in the next step, we're going to acidify the solution. So each of the ester functional groups that we see here, they will both be converted into a carboxylic acid. Now the next step is to heat the solution. And so decarboxylation will occur, so we can get rid of one of the carboxylic acid functional groups. And so we're going to have 1, 2, 3, 4, 5 carbons attached to this carboxylic acid molecule. So in this case, we have hexanoic acid as our product. Now let's work on another example. So let's start with diethyl malonate again. And this time we're going to add 2 R groups. So in the first step, we're going to use sodium ethoxide. And then in the second step, let's use ethyl bromide. And then in the third step, sodium ethoxide again. And then in the fourth step, we're going to use butyl bromide. And then in the fifth step, H3O plus, followed by heat. So go ahead and predict the major product for this reaction. So let's write up a mechanism, just like before. So the first step is going to be the same, and that is deprotonation. And in the second step, we're going to alkylate this ion. So we're going to react it with ethyl bromide. And so now we have our first R group. So we're going to add 2 extra carbons. And then we're going to use ethoxide again to get rid of the second alpha hydrogen. And so now we have a negative charge again on the alpha carbon. And so at this point, we can react it with another alkyl halide. And so the other alkyl halide that we're going to use is butyl bromide. And so at this point, we've added 2 R groups to diethyl malonate. We've added an ethyl group, and we've added a butyl group. So now our next step is to react it with H3O plus. And so we're going to convert each ester into a carboxylic acid. And then finally, we're going to heat the solution, and decarboxylation will occur. So now let's count the longest chain. 1, 2, 3, 4, 5, 6. So we have hexanoic acid again. And on the second carbon, the alpha carbon, we have an ethyl group sticking out of it. And so this is the product for this reaction. Now, starting from the same reactant, what reagents do we need in order to make this product? How can we make that product? Go ahead and pause the video. Find the reagents that we need in order to make this product. So we know the first step is going to be sodium ethoxide. We need to remove the alpha hydrogen. Now, how many R groups are we adding? It looks like we're adding 2 R groups. So we need 2 different alkyl halides. The first thing you should do is identify the alpha carbon, and then the 2 groups that stick out from the alpha carbon. So here's the first group. This R group contains 3 carbon atoms, and here's the second one, which has 4 carbon atoms. Now, I'm going to draw the first R group based on what I see here. Now, instead of drawing the alpha carbon, add a bromine atom to where it attaches to the alpha carbon. Now, I'm going to redraw this one exactly the way I see it. And so it looks like that. And then here it attaches to the alpha carbon, but instead I'm going to attach it to a leaving group. And so that's how you can determine the 2 alkyl halides that we need in order to make this product. So in step 2, since I'm running out of space, I'm going to put it here. Step 1 was the use of sodium ethoxide. In step 2, we can use any one of these 2 alkyl halides, but I'm going to start with the one that's less sterically hindered. So in this case, propyl bromide. And then in the third step, I'm going to use sodium ethoxide again. And then in the fourth step, I'll use the other alkyl halide. Now we're not finished. In the fifth step, we need to use H3O plus, and then the last step will be the use of heat. And so that's how we can convert diethylmalonate into this particular carboxylic acid.